Yet another episode where we shall be looking at the preparation for the mathematics paper 2 for the grade 7s for this year 2025. Okay, so remember in term 4, end of the year, we write two papers, paper 1 and paper 2. So in this case, our focus is just the paper 2. So which topics can we expect in paper 2? It's basically term 3's work as well as term 4's work. Okay, and which topics are those? Topic number 1 for term number 3 was basically the construction of geometric figures. So construction of figures. So under here, you guys might have looked at how to measure and construct angles. Okay. You also did talk about the different types of angles. Besides the types of angles, you also talked about the geometry of the straight lines. Okay, the parts of a ray, the parallel lines, the perpendicular, a line segment, and all those. So they all fall under the construction of figures. And then topic number 2, we have the geometry of 2D shapes. Okay, under here we look at the properties of different shapes. Okay, you guys might have looked at the triangles, the different types, as in how do we classify triangles based on the sides, based on the angles. You also talked about the quadrilaterals, the rectangle, square, parallelogram, rhombus, kite, and their respective properties. Okay, then besides that, you also talked about similarity and congruence. Okay, similar shapes and then congruent shapes. Okay, what we need to look out for, you need to also understand that. Then topic number 3 was the transformation geometry. Okay, transformation geometry. In grade 7, we look at almost all the 4 transformations, the translations, which some people call the slide. We have the reflections, which are basically the mirror images. There's rotation, okay? And then there's also enlargements as well as the reductions. Okay, so basically that was term 3's work. Then in term 4, what you guys are supposed to cover is basically the area and perimeter of 2D shapes. You also need to look at the volume and the surface area of 3D shapes. And then lastly, the last topic must be data handling. Okay, so basically these are the topics that will be in paper 2 for this particular year. So I'm going to use this paper just as a guide or a dummy, just to help us in our preparation for that examination. I hope all these topics will be in this paper. So the paper is 50 marks for 1.5 hours, okay? Instructions, read all the instructions carefully. We have 10 pages, including the cover page. We have 6 MCQs. Circle the letter next to the correct answer. Then 2 to 7, we must use the spaces, show all the workings. The use of the calculator is allowed. Good. Write neatly and legibly. All right, question number 1, which is section A. They're telling us that an angle that is equal to 180 degrees. Okay, so angles that are equal to 180, we know that that is a straight line. So it can be called a straight line or basically a straight angle. So basically that is option C. And then a dash, dash, dash is a line with a definite starting point and a definite end point. So that is a line segment, which is option A. And then what is the name of this quadrilateral? So by looking at it, we feel like these lines are parallel. So this shape is a trapezium. Okay, it cannot be a parallelogram, cannot be a rhombus, it can be a kite. So trapezium is the best answer. And then 1.4, how many lines of symmetry can we get here? So remember, line of symmetry is more like mirror lines. Okay, how many mirror lines can we have so that we get the same exact shape on the other sides? So it's basically one line of symmetry. I'll go with option D. Okay, because the bottom part looks like the top part. You cannot say that you're dividing it here because this side is not going to look the same as that. Okay, then if that is correct, we can have someone, no, it's not. 1.5, if the length of a rectangle is 8 centimeters and the breadth is 4 centimeters, what is the perimeter? One thing we know about perimeter is that it's the distance, the total distance around the shape. Okay, so if that is our rectangle, if the length is 8, the breadth is 4, the length is 8, the breadth is 4. From our properties of 2D shapes or quadrilaterals, we know that the opposite sides are equal. So we need to add up all these numbers together so that we have 8 plus 4 plus 8 plus 4. So that is a 12 plus a 12, which gives us a 24 centimeters, which is that one. Then lastly, 1.6, the following data set shows the marks of mathematics test for the grade 7 learners. Okay, maybe this test was out of 50. Okay, they never told us that's 100. So we're going to assume it's 50, né? But it's not a big deal. So we have 21, 32, 44, 32, 21, 25, 31, 42. What is the mode of the data? So mode is basically the number that appears the most, okay, compared to the rest of the data. So we have 121, we have 221s. We have 132, 232s, 332s, 142, 144, 125. So 32 becomes the mode because it is appearing 3 times compared to the rest of the information. Okay, then question number 2, which is the free response questions, construction of geometric figures and the geometry of straight lines, 8 marks. The following diagram below shows the measurement of an angle. Answer the questions that follow. What is the size? So we can see that all of this is a 90 degree. So what type of angle is this? 90 degrees known as a right angle. A right angle. Then 2.2 in the figure below, C is the center. Thank you. Use the figure to complete the statements below. What do we call BD? So whenever you're given 2 letters, those 2 letters will represent the exact distance. So when they say BD, meaning the distance from here, B, up to point D. So for as long as the line is from the circumference, the other circumference to the center, that is known as a diameter. And then what we call the line AB. So AB, the line that cuts 2 points of the circle, but not through the center, that is known as a chord. And then what we call the line CD. So from there up to there, from the center to the circle, that's known as the radius. Okay, then they want us to define the following terms. What's a ray? So we know that a ray is a line with a starting point. Okay, but no end point. Okay, because usually an arrow kind of format. For as long as we see the arrow heading, that's basically a ray. Starting point, no end point. And then parallel lines, we are saying these are lines that are equidistant. Lines that are, I will say, equidistant apart and will never meet. Or you can give us your definition based on your understanding, for as long as there's an interpretation that these lines are not going to meet at any one point. What I mean by equidistant is that the distance between the two lines will be the same continuously. An example, when you talk about the railway tracks or the road of the train. Okay, perpendicular lines, we are seeing that these are lines that intersect, okay, at right angles or at a right angle. Or someone can say lines that intersect at 90 degrees. Those are perpendicular lines. Normally use that symbol as well. Then 3.1, which is the geometry of 2D shapes. Study the diagrams and classify the triangles according to their types. Okay. So remember, classification of triangles is based on angles and also based on the sides. Okay, so with the angles, we have the equilateral, we have the isosceles, we also have the right angle. And then with the sides, we also have equilateral. We also have the scalene. Now the angles, we have obtuse angled also. And then we have isosceles as well. Okay, so classify this. So triangle A, we're seeing that two sides are equal. So that's known as an isosceles triangle. And in this case, there's just a 90 degree. We don't care about the size because I did not mention anything. So we're gonna say this is a right angled triangle. Then 3.2, classify the quadrilaterals by writing their names. Okay, so a shape that has two adjacent sides, two sides that are next to each other being the same, is what we call a kite. And then this shape, when I look at it, it feels like this side is equal to that side, and this side is also equal to that side, meaning that this is most likely to be a rhombus. Okay, because the angles are not 90. Otherwise, it was going to be a square. Question 3.3, look at the following figures and answer the questions below. Group A, Group B, Group C. Which group has similar 2D shapes? Now, when the shapes are similar, there has to be a small shape and a big shape, okay? But when you look at the versions, they must be exactly the same version. What do I mean? If I look at group B, I feel like it's the perfect, whatever, the perfect answer for this question. Why? Because this is a small triangle, this is a big triangle. When you look at the direction of the angles, they are exactly the same. Why are we not choosing A? These shapes are exactly the same size. So rather, these ones will be congruent. We are saying these are similar. Why can't we use C? This is a square, and then this is a rectangle. These are two different shapes. The shape must be the same. Triangle, triangle. Whatever shape it is, it's the same as that. All right, 3.4. Study diagram below and answer the following questions. What type of quadrilateral is this? So we know that this is a parallelogram. Parallelogram, the cousin of a rectangle, but the angles are not 90. Then name a side that is equal to AB. So if this is AB, the opposite sides must be the same. So the side is going to be CB. What is the length of BC? If this is a 2,5, even this side we must have a 2,5 meters. Okay, because opposite sides, even the markings themselves are indicating. All right, then question 4, which is the transformation geometry. Study diagrams below and answer the questions that follow. Triangle ABC has been translated. Okay, it has been moved around into triangle A prime, B prime, and C prime on the grid. Describe the transformation that took place. So when it is a translation, you need to talk about the move in the X and then also the move in the Y. So if I look at point A, let me use point A because you don't need to use all the points, just use one point. How many blocks did A move to the right? How many blocks did A move to the bottom? Okay, so the bottom we have 1 block, 2 blocks, 3 blocks, because we can find A here. So from there up to there, it's 3 blocks. And then from here up to here, it's going to be 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So how do we describe this? I'm going to say that move or slide. We have 7 units. A block is a unit, né? 7 units or 7 blocks to the right. And then 3 units down. Okay, so when you move down, you must indicate down. When you go up, you have to tell us up. When you go to the left, it should be left. When you go to the right, it's right. So basically, that is how you describe the translation that took place. So you move 7 units to the right, and then 3 units down. Then 4.1.2, they want us to draw a reflection of this mini boat. Okay, reflection is just a mirror image. No? So if this point is going to be here, since we were given the mirror line. So the distance from one point to the mirror should be the same as the image. We can connect that. Oops, we're going to get a fish. From a boat to a fish. And then we see that this point must be just somewhere there. And then this point, it's 1, 2, 3. 1, 2, 3. So somewhere there. Same point down there. And then we have this point which must be there. And then this point is 1 block away from the line. No, this point is wrong. Is it wrong or is correct? Getting confused now. Okay, let's see. When I look at this point, it's 1, 2. Yeah, it's correct. Meaning that this one is also going to be somewhere there. Then we can connect. This must go to that. Then connect to that with your ruler, please. And then connect there. And then we connect more. And then we have something like that. Okay, so from a boat to a mini fish. Okay, so that is how the shape was going to look like. Why is it looking somehow? Is it because I'm not using a ruler? Okay, but then that is the idea of the reflection. And then recognize the original triangle and its image, and then describe the transformation that was used to move from position 1 to position number 2. Now, what do you notice? That from this, if this is our point of reference, okay, what is happening is that this thing is being rotated around. When you look at the angle in between, this is going to be a 90 degrees, okay? So what is happening? We are rotating. We are rotating PQR, no, it's PRS. Rotate PRS, we are saying 90 degrees. Which direction is this? That's going to be the anti-clockwise. So 90 degrees in the anti-clockwise direction. I think that is what is happening. Because I cannot say it's a translation because it's going to be different. Because 1, 2, 3, and then 1, 3, and 1. This is going to be 1, 2, 3, 4, 5, 6. Nope. So it's just a rotation. All right, then 4.2, they want us to enlarge this shape. Enlarge all the sides of the trapezium by a scale factor of 2. Now, whenever you're enlarging, we multiply all the sides by the scale factor. Meaning that if we have 2 blocks more, at the bottom, we're going to say 2 times 2, which gives us 4 blocks. So I can start from somewhere here and have my 4 blocks there. Then if we are having 2 blocks across, then we're gonna end up with 4 blocks upwards. Okay, but now the question is, from here to here, that's more like a block, which means we must have 2 blocks to cover whatever we're having there. All right, so what are we gonna do? So 4 blocks upwards, 1, 2, 3, 4. Can put it there, 1, 2, 3, 4. Can put it there, and then connect this. And then connect this to somewhere there. And then we have this. So that should be our trapezium after being enlarged, after being made bigger. And then 4.3, they want us to resize the shape below using a scale factor over 0.5, and then they want us to draw the reduction. So resizing is more like decreasing or reshaping something. Now, if the scale factor is less than 1, meaning that the original shape is the final shape is going to be smaller. Okay, 0.5 is just the same as a half, meaning that the distances we have to divide them by 2. Where we have 2 blocks here, we're gonna end up having just 1 block. Okay, 1, 2, 3, 4, 5, 6, 7. We have 7 blocks now. Does it make sense? So 1, 2, 3, 4, 5, 6, 7. 7 divided by 2, gonna get 3.5. Okay, so 1, 2, 3.5, somewhere there. And then here we have 1, 2, 3, 4, 5, which is gonna be a 2.5, which is somewhere there. But this is 2 blocks, which means supposed to be a 1 block. Yeah, it is, because it's a 1/2. Perfect. Then we have 1, 2, 3, 4. Then we're gonna have 2 blocks. And then the rest is history. Just connect and then get your shape. Okay, please use your ruler. I don't have a ruler as yet, but I'll source out one so that we have proper shapes. Okay, so that is our kind of shape that we have. Then question 5, which is area and perimeter, they want us to calculate the area of a triangle. So we know that a triangle, the area is given as a half multiplied by the base multiplied by the height. So a half, this 6 is the base, this 4 is the height. So a half times 6 times 4. From your multiplication, you know what to do. Multiply the numerator separately, denominator separately. So that's going to be a 24/2, which is 12. But area is measured in square units. Then 5.2, convert the following units of area. So we know that if we have kilometers, meters, centimeters, and millimeters, if you're converting from kilometers to meters, you multiply by 1,000, we multiply by 100, we multiply by 10. If you're moving backwards, you divide by what we're calling the conversion factors. Now, if ever we're dealing with units of area, meaning that we need to square these conversion factors, like if we have kilometers squared, meters squared, centimeters squared, and then millimeters squared, the conversion factor is going to be times 1,000 squared, times 100 squared, times 10 squared. And then the division is also going to be the same. Divide by 100 squared, then divide by 1,000 squared. Now we know that kilometer is the biggest unit, and then millimeter is going to be the smallest unit. When you're converting from a big unit to a small unit, you multiply. Small unit to a big unit, you divide. Okay, so from centimeters to millimeters, okay, from centimeter squared to millimeter squared, multiply by 10 squared. So it's going to be 3 times 10 squared. We know that 10 squared is the same as 10 times 10. This is going to give us 300 millimeters squared. And then if we have 5 meters squared to centimeters squared. So meters squared to centimeter multiplied by 10 squared, sorry, 100 squared, which is going to be 5 times. This is going to be 100 times 100, which is like 10,000. So that's going to be 50,000 centimeters squared. 5.4. Calculate the perimeter and the area of a square that's having this length. Convert your answer to 1 decimal place. Okay. So he's saying if this is our square, not that a square, all the sides are equal. If that's a 1,5, we know that perimeter is going to be length plus length plus length plus length, or just 4 times 1 length. So 1,5 plus 1,5 plus another 1,5 plus another 1,5. So this gives me 6 but centimeters. Okay. Then when it comes to the area, we just set length times length. So 1,5 times 1,5. So you're allowed to use your calculators in this manner or in this question, because it becomes, easier to work with. And okay, so 1,5 times 1,5, I'm getting 2,25. This is centimeters squared. But then they want the answer to 1 decimal place, so 1 number after the comma. So this 5 is going to increase the 2 to give us 2,3 centimeters squared. So this is what the question wanted. Okay, and then 5.4, calculate the volume of a cube that's serving that. So we know that a cube is a 3D whose sides are basically squares. So that's a 3, a 3, a 3 everywhere. So volume will be length times the length, which is 3 times 3 times 3, which gives us 27 millimeters cubed. Perimeter would have been just millimeters for 2D shapes. Area, millimeters squared. Volume is cubed. All right, then 6.2. The surface area of a cube is given as this. They want us to calculate the volume of the cube. So with this question, what we need is basically the side. What is the length of one cube? We know that the cube has 6 faces, just as you can see. Okay, but now if I say this is L, this is also L. So the area of one face is going to be L times L, which is L squared. Now, if I'm talking about surface areas, like I'm adding up all the faces, the area of all the faces, meaning that the surface area is given as 6 times L squared. Now, if I have 150 as my surface area is equal to 6L squared, let's divide both sides by 6. 150 divided by 6 gives me 25. And then I need to find the square root of 25. What does this mean? It means that my side is just a 5 centimeter. But the question wants what? The volume. So volume is length times length times length, or someone can say length cubed. So it's a 5 times a 5 times another 5, which gives us 125 centimeters, but cubed. Okay, then 6.3, convert the following. Okay, so we're moving from, remember what we said, kilometers. Now we're dealing with cubed, meters cubed, centimeters cubed, millimeters cubed. We're moving from centimeters to meters, which means we're going to divide by 100 cubed. So 2 million divided by, this is 100 cubed, which is 100 times 100 times 100. Why am I saying 2? Hello, it's 2 million. So it's a 2 million. That's divided by 1 million. The answer becomes just 2 meters cubed. And then 80 centimeters cubed to milliliters. Now what we know is that 1 centimeter cubed is equal to 1 milliliter. Okay, that's just the same thing, meaning that this must be just 80 milliliters. All right, question number 7 that talks about data handling. The data below shows the marks for the math test for the grade 7 learners. Display the data in a stem and leaf. So a stem and leaf is basically a diagram or a representation where we have a stem there, and these are the leaves or the leaf. What does this mean? That if you're given numbers that have 2 digits, let's say 22, the last number is the leaf. This is the stem. If you have just 1 digit like 1, we always add a 0 there. So that 1 becomes the leaf, and then 0 becomes the stem. If you have 3 digits, 1, 2, 3, the last digit will be the leaf, and then the first 2 numbers will become the stem. But now, since we're dealing with just 2-digit numbers, which means it's just going to be straightforward. Okay, so the use of the stem and leaf diagram is basically to rearrange data in order, okay, from the smallest to the biggest. Now we can see that the smallest number here is a 21. So 1 is a leaf, 2 is a stem. So the smallest stem is going to be a 2. We have numbers that are starting with 3. We have numbers that are starting with 4. Okay, so with 2, the smallest one is a 1. We write the 1 there. Then from there, we have a 5. Just put the 5, and then we put a 6. Then the stems of 3, we have 2 33s. So we're going to write 3 and a 3. Okay, we're done with this. And then with 40, we have 42, 43, and 44. 42, 43, and then 44. So the stem together with the leaf. So sometimes you can be asked to put a key and tell us that 2/1 means 21. All right, so that is your stem and leaf representation. Then 7.2, they're telling us that a shopkeeper recorded the sales at his shop during one day. He drew a histogram of the results as shown below. Okay, so from 9 to 10, this guy made only 5 sales. Does this make sense? Okay, let us make sense out of this. So we're going to assume this is a 5. Probably this is a 10, because what I see doesn't make sense. Let's call this a 15, 20, 25, and then 30. Okay, just on the line. It cannot be in between the lines. No, that would be incorrect. So how many cells took place between 2 and 3? So we know that 2 is the same as 14 hours. 3 is the same as 15 hours. So between 2 and 3, which means our focus is this, which is 20. It's in between. Okay. Let's see if that's the correct representation. Okay. So it's in between 20 and 25, which is like 23 cells. Okay, we just estimate, since remember we're dealing with cells that are whole numbers, we cannot have like half a cell or a quarter of a cell. Otherwise, it was going to be 22.5 cells. But in this case, I'll say it's a 23. Then at what time of the day did the shopkeeper make the greatest number of sales? So the greatest, we look at the tallest bar, which is this one at 25 sales. So between 1 and 2. So just tell us 13 hours up to 14 hours. Okay, so just like that, we don't need paragraphs. Yeah? Question number 7, grade 7 learners were asked, okay, to graph their birthday months. Study the graph below and answer the questions. The red is for the girls, blue is always the boys, yes. So the boys have more birthdays in January. The girls have it more in the love month, February. March, the girls win. April, okay, and so on and so forth. Then the first question is, how many learners have their birthdays in October? So when you look at October, it's unequal, it's a tie. We have 10 boys and then 10 girls. So meaning that's going to be 20. So 10 plus 10 gives us 20 learners. Okay, so which means this grade 7 is having a big class now. So which month has the highest number of girls? So we look for the highest red or the tallest red, which is May. Okay, so we're going to say May has the tallest or the highest number of girls because that's when the red is highest. The next, which month has the least number of boys? So least means the smallest. So let's look for the shortest blue. The shortest blue is here. And they're asking for which month, which is just July. All right, so that brings us to the end of this paper. Okay, and I wish you guys all the best in your preparations. Please and please remember this is mathematics. We always have very many methods to use. So whichever question that you look at, please try to use a method that makes you understand better. Okay, whatever I've used here is just a sample of what is expected of us. Okay, so I'll stop there and then I'll sign out. Let's meet whenever we meet. All the best, and I wish you good luck in your examinations. And I pray that you all pass to the next grade. Bye-bye.